Consider the differential equation on the board. How can we solve this differential equation? What do you think we can do? Well, you notice that the derivative is separated from the derivative functions. So if that is the case, then the use of the direct integration method will be best for us to use. So let's integrate both sides with respect to x. So the integral of the y over the x with respect to x will be equals to the integral of 2 tan x, then plus 2x plus 3 in the bracket of 1 by x minus 1 by x squared plus x squared e to the power of x to the power of 3 dx. Now, you notice that the integration of the y dx with respect to x will be nothing but y, which is the dependent variable. Now, what about the right hand side? How can we integrate that? First, let's try to expand this, but let's try to quickly review what we understand in indices. There's what we call negative law of index in indices. The law says that when you have x raised to the power negative a, this is the same as 1 divided by x to the power of a. One good thing about laws in indices is that they work in a vice versa way. If this is what you're having, you can turn into this. And if this is what you're having, you can also turn into this. If that is the case, we want to turn most of these fractions to negative index. So let's do that. So right now we can have the right hand side to be the integral of 2 tan x plus 2x plus 3, then in the bracket 1 by x can be expressed as x raised to the power of negative 1. The minus 1 by x squared becomes x raised to the power of negative 2. Then we have plus x squared multiplied by e to the power of x to the power of 3 dx. At this point, we can expand the parentheses by making use of 3 since it is the coefficient. Then we can have y to be equals to the integral of 2 tan x plus 2x. Then what I will do is to distribute this 3 to each of the tan within the parentheses respectively. Then I can have plus 3x to the power of negative 1, then minus 3x to the power of negative 2, plus 3x squared e to the power of x to the power of 3 dx. Now, since I can distribute the integral for each of the terms respectively, since that's one of the properties of integration, then I would like to do that right now. Then I can have the integral of 2 tan x dx plus the integral of 2x dx, then plus the integral of 3x raised to the power negative 1 dx, then minus the integral of 3x raised to the negative 2 dx, then lastly plus the integral of 3x squared e to the power of x cubed dx. Okay, let me just squeeze that over here. Hopefully you can see that. Now let's try to integrate each of those terms respectively. Hopefully you're following. So we now have y to be equals the integral of 2 tan x dx will become negative 2 ln absolute value of cosine x. This might be a little bit tricky for you to understand, so let's try to show it out. We all know that tan x is the same as the ratio of sine x by that of the cosine x. So what I would like to do, let me use different colors so you won't misquote it. I will still come back to this, but I just want to make a clarification on how the integral of 2 tan x turns out to be this. So now we have the integral of 2 tan x dx. So if we take the 2 to the front of the integral symbol, then we have 2 integral of tan x dx. Now we said tan x is this, so definitely this will be equal to integral of sine x over cosine x dx. So what I would like to do right now is to make use of the u substitution. I will let u to be equals to cosine x. So if u is equals to cosine x, then the derivative of u with respect to x will be equals to negative sine x. I hope you know that the derivative of cosine function is negative sine function. Now, if I should solve for the x from this equation, then I should have the x to be equals to the u divided by negative sine of x. So what I would like to do is to replace cosine x with u and the u and the x with the u over negative sine x. So therefore, I'm going to have this. Let me cut this out. I'm now going to have 2 integral of sine x all divided by u, cosine x has become u. Then multiply by the x is this. So that's going to be the u divided by negative sine x. Perfect. So I don't really need any of this anymore. So I can get rid of them. So I just want to be doing each and every one of them one after the other, so you can get it straightforward. Now at this point, you can clearly see that negative sine x cancels positive sine x, left over is negative 1. And if I bring out the negative, if I bring it to the front of the integral symbol, then I'm going to be left over with negative 2, the integral of the reciprocal of u with respect to u. Now, the integral of 1 over u is simply equals to the natural log of u, taking the absolute value of u. Now, earlier we said u is equals to cosine x, so we need to substitute back, and that makes us to, at the end of the day, got the integral of 2 tan x to be equals to negative 2 ln cosine x, and that is how we got that. Hopefully you got that. So let's continue. We have integrate that of 2 tan x. So what I would like to do is just to cross it. This has gone. Now on to this. What is the integral of 2x dx? That will just be equals to plus, okay, let me use blue color, 2x squared over 2. And notice that these 2 can cancel out, and left over will just be x squared. I will write that later. Let's continue. So unlike before, I'm just going to cross that as well, since we are through with that. Now on to the next term. What is the integral of 3x raised to the negative 1 dx? Well, what I would like to do is to bring the 3 to the front first. So that will be 3 integral of x raised to the negative 1 dx. Now, x raised to the negative 1 can be expressed as 1 by x. So definitely, this will equals to 3 integral of 1 over x dx. Now, the integral of 1 over x is simply ln x. So at the end of the day, the integral of 3 raised to the negative 1, 3x raised to the negative 1 with respect to x is simply 3 ln x. And that is it. So I'm going to cross that out of the way, but let me try and get rid of this first. So we are through with this. We got it to actually equals to 3 ln x. Now, on to the fourth term. What is the integral of 3x raised to the negative 2? So unlike before, let's bring the 3 to the front of the integration symbol. Then we have 3 integral of x raised to the negative 2. The x, okay, oops, there's no the x right there. So finally, we can integrate this function. We can have 3x raised to the negative 1 all divided by negative 1. How did I got that? I just added 1 to the index and divided by negative 2 plus 1. So we should end up with this. Now, if we simplify this forward, we can clearly have negative 3x to the negative 1. Now, a negative sign is outside the integration symbol earlier. If we multiply with this new one, then it will makes the whole term to be positive. And therefore, we are attaching positive 3x raised to the negative 1. And that is it for that part as well. So let me cross that as well. Now, on to the last term, which is this. Well, let me try and create no more space by getting rid of this one. So what is the integral of 3x squared e to the power of x cubed? Since 3 is constant, as we have been doing earlier, let's bring it to the front. So this will imply 3 integral of x squared e to the power of x cubed. So what do you think we can do to evaluate this integral? Well, let's try to make the x cube we have to be an index of the exponential symbol to be equals to u. So let x cube be equals to u. So therefore, we can have the integral to be equals to 3 integral of x squared e to the power of u dx. Before this can be integrable, we must have this to be with respect to u and not with x. Otherwise, we can't integrate it yet. So let's try to differentiate this function. What is the u over the x? So this will definitely be 3x squared. And if I solve for the x by cross multiplying, then we will have the x to be equals to the u over 3u squared. Now, what we are going to do is to replace the x with the u over 3x squared and not 3u squared. Thank you. So let's do that. So we can now have the integration to become 3 integral of x squared e to the power of u, then multiply by the u over 3x squared. Now you can clearly see that at this point, x squared cancels out and 3 as well cancels out. Left over will just be the integral of e to the u. And at the end of the day, the integral of e to the x is still e to the x. So definitely, we are almost there. So the integral of e to the u with respect to u is simply e to the u. But earlier we said u is equals to x cubed. Then definitely the integral will simply be equals to e to the power of x to the power of 3. Since it's going to be positive, we can attach it to the following ones, and that will be e to the x to the power of 3. And that will be the equation itself. So finally, y will be equals to negative 2 ln cosine of x plus x squared plus 3 ln x plus 3x raised to the negative 1 plus e to the power of x to the power of 3. And this is the solution to this differential equation. Hopefully you find it helpful. Thanks for watching. See you guys in the next video. Bye for now.